Hey guys, good morning, good afternoon, good evening. This is Ankush here from Alif Consulting. Welcome back in our partner enablement video series. In today's video, we will be going to talk about how to sell a serverless web application solution to a customer and what are the benefits or use case of having a serverless web applications. Well, here is the agenda of this video. So we will be going to talk about what is a serverless compute is, what are the benefit, what are the application benefit is there, what are the use case, and then we'll be going to walk through with the one of the reference architecture, what are the key component, what are the scalabilities options are there, what are the disaster recovery options are there, and then later on we'll be going to show you or we're going to explain you how you can have a cost optimizations while having a serverless applications or running on a serverless architecture. And later on I'm going to show you one quick demo using the Azure function where I will be having a one sample uh, functions created for one of the trigger, and that will be I will show you how exactly that has been working here. So let's quickly jump to the introduction. So serverless computer allow you to build and run the application and serve without thinking about the servers. With serverless application or serverless computer, your application still run on a server, but all the server management is done by Microsoft. Using Azure and its serverless platform, you can build, deploy application cost effective service that provide you built-in application availability and flexible scaling capabilities. This lets you focus on your application code instead of worrying about provisioning, configuring, and managing the server. So with the serverless application, you don't need to worry about anything. You don't need to worry about how exactly you will be going to manage the server, how exactly you're putting the securities, how exactly you're going to think about patching, doing the security updates, doing the OS update, managing the space, managing the hardware. That's something you don't need to worry about. In serverless computing, you only need to worry about only for your code. Even in a web app, you need to manage the app service, right? You need to do the configuration, you need to uh, do the basic configuration there inside the app service. But with this serverless platform, which is also known as Azure Function, is pretty much straightforward. You no need to worry about any kind of application availability or flexible scaling capabilities. You just need to focus on a core. That's it. Rest of the things will be taken care by the Microsoft or through the Azure function. Now let's understand what is the benefit of having the serverless architecture, right? So the cost, definitely there is going to be a very less cost, because while you are running the application on the VM, you need to pay for how many hours you are running the VM. But with the serverless architecture, you will be only going to pay for per invocation basis, right? Scalability, function instance are automatically created and removed in response to traffic variation within a boundary of concurrency limitation. Productivity, engineer who use the serverless can simply deploy their code without to manage any server, which help accelerate the delivery cycle and rapidly scale the company operations. Now, what are the benefits of a serverless application? Low maintenance, you don't need to worry about any kind of things. You just need to focus on code. Low cost, because you will be only going to charge for how many requests you are going to put there. Easy to scale, no infrastructure management. So these are the four major application benefit when you are running on a serverless components. Well, we do have a few challenges also with the serverless architecture. Loss of the control in the serverless environment. You don't have any kind of control over the software stack or the hardware stack, because you just deploying your code, and in case of there is any issues or any outage is there, you are dependent on the cloud provider to fix it. Security, a cloud provider may run a several of their customer on the same server at the same time. If that is a shared server, it's not configured properly, your application can be exploited, right? So this is one of the biggest thing, because shared I can say a serverless architecture, or when you're using a serverless service, they are being shared with multiple on a server, and a customer may accessing you the same server from where your application is running, right? So that is something like which can exploit your application data. Performance impact: cold start are common in the serverless environment, adding a several second of latency to code execution when a function are invoked after a period of inactivity. So this is one of the true things, because let's say your function is completed and now after 2 hours you trigger the same function one more time. It may take times because ultimately that function has been already went into the inactive state, and that has to be rerun all the codes, or the all the length of the code which you have written there. Testing: yes, testing is more important when you are using the serverless application or serverless architecture. You have to test it. And vendor lock, again this is a one of the again lack, is because if you have used Azure Function specifically, if I'm talking about, you might be having a several other services like a database, messaging queue, APIs, which is being integrated with the server function application, and that you can be in but like to run the application, but it's possible to mix and match the element of different vendor services for a single provider designed to integrate most of seamlessly. Use cases: yes, there is a few use cases. If you really want to run any kind of trigger based task, building the REST APIs, asynchronization processes, security checks, CI/CDs. If you really want to have all of these use cases, uh, and your use cases are matching with this, definitely go with the serverless architecture. So serverless architecture is become a very cost effective in terms of running it, because you will be only going to pay for how many time you have run a function, but it doesn't mean that your your application is going to be compatible and with the serverless architecture. So you have to think about it, and when you're selling the solution to the customer, you have to gather the application information. So let's say if there is any functions, like if your application is putting any kind of data in the storage, or processing any kind of data, or migrate or changing or converting any kind of data, that's where your function can be there and you can trigger the function. Or maybe there is a REST API working with uh, your application, and your REST API is used by a third party provider, or customer app REST API is basically used by a third party provider to get the data or put the data. In that way, the serverless architecture can be come in place, can help you to solve the problem. But in terms of running the applications, definitely if you are having a serverless architecture, you may need to run a multiple uh, app functions also. You may need to write a multiple functions also. So it's better where you can have a combination of web app, databases, and Azure functions. So web app can be used for a front end, and the Azure function can be used to trigger any kind of work which is required after user have put the data on the web app. And then in the back end, you can use a database like a SQL database or Cosmos database to store that information. Let's quickly jump on the reference architecture. So in this reference architecture, you have two things. You have a CDN which has been attached with storage account, and that is having the the that is having the all the images. And then at the end, you have a API management with the functions which is integrated and putting the data on the Cosmos DB. At the same time, as a backend, you have a CI/CD pipeline which is having your Azure pipelines. You are having the GitHub actions, and then there is end-to-end monitoring is happen through the Azure Monitor. So in terms of this architecture, there is the two components is there. One is the backend as a service, and second one is this function as a service. So backend as a service, backend cloud service such as a database storage provide the APIs that enable the client application to connect directly to this service. Function as a service: in this model, a function is a piece of code that is deployed to the cloud and run inside a hosting environment that completely abstract the server that runs the code. So on the function, you can write your code, you can put it there, and you can basically create the triggers. That's it. As soon as you trigger it, is happened, or application have put in any information, the trigger will be automatically get started and process that information which is required. Now let's quickly jump to the components. So there is a few components are there inside this architecture. First, a blob storage. Yes, the blob storage is there, which is basically hosting the static websites such as HTML, CSS, and JavaScript files. And then it basically using the CDNs there. So CDN is basically getting cache of the content which is in the storage account for lower latency and faster delivery of the content. Then you have Azure Function. Azure Function is a serverless compute option. This use an event-driven model. When a piece of code is invoked by a trigger in this architecture, the function is invoked. When a client makes the HTTP request, the request is always routed through the API gateway. API gateway, API management. API management provide a API gateway that sit in the front of HTTP function. You can use the API management to publish or manage the API used by the client application. And then you have Cosmos DB. So the Cosmos DB is a multimodal database service. For this scenario, function app fetch the documentations or the information from the Cosmos DB in response to HTTP GET request from the client. And then you have a Azure Active Directory, which basically used by a user to sign in into the web application. Azure Monitor will be going to use there to monitor the applications. Azure Pipeline will be there to provide you a CI/CD, and then GitHub Action Workflow is the automated process that set up you in the GitHub repository. You can build, test, package, release, or deploy any project on the GitHub with this workflow. So these are the component, and again these components may vary on your environment. You might not having the Azure pipelines where your developer might using the Visual Studio to push the codes, and for the Cosmos DB you might having the SQL databases to fish some kind of information. So with the reference architecture it's going to give you the idea, but at the end of the day your components may vary with the way you are designing the architecture, right? So that's how your component may vary. Now scalability options for the function, since it's a consumption plan, HTTP trigger scale based on the traffic. This is a limit number of concurrent function instance, but each instance can process more than one request at a time. For Azure service plan, that HTTP trigger scale according to the number of VM instance which can be fixed value or can auto scale based on the set of auto scaling rules. And then we do have a Cosmos DB. So the Cosmos DB throughput capacity of Cosmos DB is measured on request unit. One request unit correspond to the throughput to get a 1 KB document. In order to get a Cosmos DB container past 10,000 RU, you must specify a partition key when you are creating the container and including the partition key in every document that you created, right? So this is the related to the Cosmos DB. So it's like you have to specify, you have to create a multiple partition keys, and all of those partition keys you need to put the data when you are getting a more than 10,000 request units. Third, API management can scale out and support rule based scaling. The scaling process take at least 20 minutes. If your traffic is busty, you should provision for maximum bus traffic that you expect. However, auto scaling is useful for handling hourly or daily variation in the traffic. With the Azure APIs management, actually it's take up to 20 minutes to do the scaling. So you need to think about it when you are creating your app service, the API management, and accordingly you have to think about it, or you have to provision the sizing. Disaster recovery, yes, you need to use API management in the multi-region deployment. That will be going to allow you to perform a disaster recovery. Traffic manager can be used for HTTP request if function app running in a one region is become unavailable. That's again you need to deploy a function in two regions. Cosmos DB support a multiple write region, which can enable write to any region when you add your Cosmos DB account. If you don't enable the multi-write, you can still fail over the primary write region. The Cosmos DB client SDKs and Azure function binding automatically handle the failover, so you don't need to update any application configuration settings. So with the Cosmos DB, either you can have a multi-region deployment, or either you can do your failover for your for your primary reason. So in that case, if you're using any of these options, you don't need to worry about any kind of application changes. Cost optimizations, yes, you can do a little bit of cost optimizations as well. For the Azure functions, you do have a two types of models. You can have a consumption plan. Compute power is automatically allocated whenever code is running. Second is app service plan. A set of VM is allocated to your code. This plan defines the number of VM or the VM size. So accordingly, you have to select. If your function is going to be run 24/7, go with the app service plan. If your function is going to be run once in a time or two, once in a day or twice in a day or maybe 10 times in a day, go with the consumption plan. But again, you have to think about it, how much time uh, that a function is going to be take. Let's take an example. To complete one that function one time, it's going to be take 5 hours or 8 hours. There's no sense of having the consumption plan, because ultimately your app service plan is, sorry, the Azure function plan is going to be run 24/7. In that way, you have to go with the app service plan. For the Cosmos DB, you have to think about it, how many requests you need per second is going to be there, and accordingly you have to provision the Cosmos DB. For CDN, again, CDN rate may differ depend on the billing reason and plus the type of CDN you have used. The physical location of client is not billing reason. Any HTTP request or HTTP request hitting on a CDN is billable event, which include all these type of response. Either it's a success, failure, or other. Different response may generate different traffic amount. To lower down the cost, consider increasing the cache TTL by caching the resource file for a long duration and setting the long TTL possible on your content. So CDN is again is a billable component, and you need to think about it. You need to increase your TTL values when if you really want to lower down your cost, and in that way your caching time is going to be increased, and your TTL for your request will be going to be increased. Now again, if you really want to know more about CDN, if you really want to know more about the app service plan, and if you really want to know how the traffic manager work, there is a link in the description. Please go ahead and check out. Let's move to the demos. In the demo, I would be going to show you the one of the apps, the function which I have created, and I will be going to show you how exactly it's run. So let's quickly jump to the Azure portal, and here is my function. This function is completely up and running, and this is on Y1. This is the app service plan which I have created, and it's running on a Windows. Now if you go inside the functions, you would be able to see there is a one function which I have created, and if you go inside the function, you would be able to see what kind of code I have created. It's pretty much simple and straightforward. It's just a one function I have created. This is a very basic functions which I have created, right? And it has, is there any integration with it? So you would be able to see these integrations. If there is any integration, so you will see there is a no integration has been there. It's just a very simple trigger which I have created for this function, and you can see if there is any functions keys or values are there. So you would be able to see what are the function keys is there. At the same time, you do have a API keys or API files which you can enable or you can see. So in this function, this is the JSON host file which I have, or in the API key I do have a values which is set it there. So I do have a master value or I do have a default value, and then I do have a deployment slot same as a app service plan. Again, if you want to understand what is the CDN, what is the app service plan, and how exactly a SQL database work, there is a link in the description. Please go ahead and check it out. And to run this, so and then it's a app service plan, so you will be able to see what kind of app service plan it's have. And if you really want to scale or want to see what kind of quota for this app service plan, you can go ahead and check that quota as well, right? So what is your quota and how much has been used, you would be able to see here. So it's a 1 TB, but it's just like a very minimum used here, so that's okay. Now how to run the function? So in my this function, I already have a function running. So this function is there on the right. As soon as you hit on, you will see this trigger has been successfully executed. Pass a name in the query string or in the response body for personalize the response. So this information has been coming from my function, the function which I have triggered it, right? So if I change anything in the function, it will automatically get changed to my value, which is here also. So this is the trigger, right? And for that to change it anything here, I need to go inside or inside the uh, the Visual Studio from where I have created, and then I can uh, do the pasting. So as soon as in this function is will be get triggered, and the function the configuration which you have defined would be working executed as per the plan which you have defined. And now in my case, the function pretty much straightforward. I don't have any kind of backend here, but in your real scenario there would be a backend going to be. So your function need to be wisely added, right? And then you can define your output and inputs inside your codes, and your customer can basically create and use it as a microservice as well. Well, that's it in the demo. I hope you like this video. If you like, please click on like and subscribe for more upcoming videos. Feel free to reach us if you have any questions. Thank you.